Hello and welcome to section 4.2, negative exponents. Now in this section we're going to learn about a type of exponent that will be very important when we start dealing with scientific notation. In the last section we took a look at 5 basic exponent rules, and at this point I would like you to think about those 5 rules. So pause the recording and see if you can write down as many of those rules that you remember from our last session. When you are done, hit play and we will continue with the lesson. Okay, I hope you've had a chance to jot some of those exponent rules down. So let's review them because we will continue to use them today. Now the first rule that we looked at, although you may have listed these in any order, was the rule that says if I have x to the m times x to the n, I can simplify that by adding the exponents together. So it becomes x to the m plus n. Another rule that we looked at, which was the quotient rule, was x to the m over x to the n. And so if we're dividing these two expressions, we can simplify it by subtracting the exponents. The third rule that we looked at, which is one of my favorites, the zero exponent rule, it simply states that if you have any base raised to the zero exponent, that always will equal 1. The fourth rule we looked at was the power rule, which says if I have x to the mth power and then raise that expression to another power, this becomes x to the m times n. Now, when you're looking at rule number 1 and rule number 4, you need to be very careful with these two rules. Notice that in this one you add and in this one you multiply. So these two rules can be very easily confused. So you will want to be very careful when you are using those. Now the last rule we went over is very similar to rule number 4. It's actually an extension of that, and it's called the expanded power rule, which says if I have a bunch of values inside the parentheses, and the a and b might be numbers and the x's and y's might be variables, and I raise that to the mth power, then that mth power applies to everything inside the parentheses. So I would have a to the m, x to the m, over b to the m, y to the m. So those were the 5 rules that we took a look at in the last section. Now let's go ahead and take a look at 2 more rules to add to this list, and then we will have all the rules that we need in order to simplify any exponential expression. So today we're going to talk about the negative exponent rule, and I want to kind of start by looking at an example of this rule. So let's say that I gave you the expression a cubed over a to the 7th. Well, this could be done in a couple of ways. But if we think about our rule from up above, which is our quotient rule, one way we could do this is we could say, well, I take a and I take the 3 and subtract the 7, and I would get a to the negative 4th. The problem is when we are working with exponents, we are always going to want to write our expressions with positive exponents. So how do I deal with this a to the negative 4? Well, let's take a look at this in another way. Suppose that I'd look at a to the 3rd over a to the 7th, and I write out what each of these means. I have a times a times a over a times a times a times a times a times a. There's got to be 7 of them down there. I think I got that right. Now, if I have the same factor on top as I do on the bottom, I can simplify that. So A and A will cancel. A and A cancels. And I have one more set of A's that cancel. But notice that I have 4 A's left in the denominator. So this simplifies down to 1 over A to the 4th. Now, this is 2 ways of doing the exact same problem. So if I've done both of these in a way that is legal, then that would state that these 2 expressions should be the same. A to the negative 4 has to equal 1 over A to the 4th. And in fact, that is exactly what is true in this particular case. And from this, we get our 6th rule of exponents, which says that if I have x raised to a negative exponent, I can always rewrite that as 1 over x raised to the positive exponent. So that is our exponent rule. Now, there's one other way I'd like to show you how this all fits together with the positive exponent rules. So let's look at another way all the exponents fit together. Let me start with 2 cubed. Now, this is an expression you're very familiar with. 2 cubed is 2 times 2 times 2. And you know that to compute that, you would get 8. Okay, now I'm going to decrease this exponent by 1. This becomes 2 squared. Well, 2 squared is 2 times 2, which is 4. Now notice that as this exponent went down by 1, the 8 and the 4 is simply 8 divided by 2. I have 1 less 2, so I can think of this as 8 divided by 2. Let's keep going. Suppose I have 2 to the 1st. Well, 2 to the 1st is a single 2, which is 2. Notice again that 4 divided by 2. Each time I decrease the exponent by 1, I'm dividing by 2 on the other side. I get 2. So now let's take a look at 2 to the 0. Well, if I think about the pattern over here, I need to take 2 and divide it by 2. So 2 to the 0 has to equal 2 divided by 2, which is 1. And so notice that that's my 0 exponent rule. It fits right into this pattern. But now I need to keep going. If I take 1 and divide it by 2, 1 divided by 2, another way of viewing that is 1 over 2. That is the same as 1 divided by 2. And so this is 1/2. So notice that this corresponds to, on the other side here, of 2 to the negative 1. 2 to the negative 1 is 1/2. And the pattern can continue. So 2 to the negative 2 would become 1 over 2 squared, which is 1/4. And again, 1/4 would be 1/2 divided by 2. So the negative exponents fit into this pattern right along with our positive exponents and our 0 exponent rule. So this is just another nice way of being able to show the relationships that you have with all of the exponent rules. All right, so now let's take a look at some examples of working with a negative exponent and some of the different situations that you might run into that you want to be careful in evaluating. All right, so keep in mind that our goal when we're working with exponential expressions, let's try that again, our goal is to always write our final answer with only positive exponents. So if you keep that goal in mind as we work through these examples, that's going to help quite a bit. So let's start with this particular example. Suppose I have 2 to the negative third. Now, that's not a legal way of writing my final answer because I do have a negative exponent, not a positive exponent. So I start by applying the negative exponent rule. This becomes 1 over 2 cubed. And 1 over 2 cubed I can simplify down to 1 over, remember 2 cubed is 2 times 2 times 2, which is 8. So I would simplify that one down to 1 over 8. Now the same works with variables and negative exponents. So let's say I have x to the negative second. I apply the exponent rule for negative exponents and I get 1 over x squared. Now unlike the previous problem, at this point I'm done. Now let's take a look at a couple that can be a little bit tricky. Suppose I give you negative 3 raised to the negative second power. Well, you want to be very careful in how you treat the negative in front of the 3. This really isn't negative 3 raised to the negative second exponent. It's actually the opposite of 3 raised to the negative 2 exponent. So you want to think about this as being a negative 1 times a 3 raised to the negative second power. So it's not negative 3. If I wanted to have negative 3, I would have needed to have written that in parentheses. Now I'm looking at negative 3 raised to the negative second power. So that's going to be different than what we have right here. So I'm going to start by dealing with that negative exponent. Again, I have negative 1 times, this becomes 1 over 3 raised to the positive second power, and I end up with negative 1 times 1 over 9, which will give me a negative 1/9. Now this next one here that I wrote down where I have negative 3 raised to the negative second power is actually going to become 1 over negative 3 squared. So notice the negative is staying with a 3 in this particular problem. So that becomes 1 over, now negative 3 times negative 3 is positive 9. So you want to be very careful here. If the negative is inside the parentheses, you're going to end up with a positive answer. If the negative is outside here like this, notice we get a negative answer. The numbers are the same, but one's positive and one's negative. So you want to be very careful to pay attention where that negative sign is at. Okay, now another way that we can view x to the negative n is as a negative exponent. Or as a reciprocal, excuse me. So if we look at a problem, for example, like 2 to the negative third times 2 cubed, there is a couple of different ways that I can view this problem. There's 2 ways now with what we've talked about that I can use. The first one would be to recognize I have the same base, which allows me to add exponent. So I could say this is 2 to the negative 3 plus 3, which becomes 2 to the 0, which becomes 1. Or I could also view this as 2 to the negative third would be 1/8 times 8 if I compute my 2 cubed. And remember, this 8 is really going to be 8 over 1, so that would give me 8 over 8, which is also 1. So there are 2 ways that you could actually compute this particular problem. And you're going to find that a lot with the problems you'll be doing over the next few days. There's more than one way that the problem can be done. So if I were to think of this as a reciprocal, where I have, say I viewed this as 2 over 1 raised to the negative third, notice that the 1/8 really is 1 over 2 cubed, which is 1/8. Now this way of thinking about your negative exponent comes in very useful when you actually have a fraction raised to the negative exponent. So for example, if I were to give you 1/4 raised to the negative second power, if you think about it as a reciprocal, you would simply rewrite the 1/4 as 4 over 1 and change the negative second exponent to a squared. So this applies the same way. And so we end up with 16 over 1, or 16. Again, raised to the power, we actually square the numerator and the denominator. The denominator just stays 1. And so we get 16. It's even nicer if we had something like 2 cubed raised to the negative second. Now again, we flip these around. So we get 3/2 raised to the second. Again, the negative exponent becomes positive when we do that. And remember, we need to square the numerator and we square the denominator because they're both inside the parentheses. So this becomes 9/4. Now this is a variation of the rule we just looked at, Rule 6, and we call this Rule number 7, which states simply that if I have a fraction raised to the negative exponent, whoops, let's bring the rule up there, then to rewrite it with a positive exponent, we simply take the reciprocal of that fraction. So that is the final rule that we have to look at today. So 2 negative exponent rules. One, if it's a whole number, it becomes 1 over, or if it's a fraction, take the reciprocal. Now I'm going to end this one at this point in time, and in the next video I will do some examples with the negative exponents and talk about one other way that you can view negative exponents.